On page 3, number 11, we're going to determine the equation of a line in slope-intercept form that goes through the following ordered pairs. Right, so to do that, to write an equation in slope-intercept form, we need to find m and we need to find b. So first step, finding m, we can either use the table method, we can use the equation. I'm going to do the table method. So I'll put in -3, -1, -1, -5. Look for my change in y's. My change in y is -4. My change in x is +2. I know slope is change in y over change in x. So that makes it -4 over +2, which is -2. So slope is -2. Now I've got to find that b. We're going to use that equation, y equals mx plus b. I have to pick an x and a y to use from one of our ordered pairs. I'm going to choose that one. Could have chosen -1, -5, but I didn't. So y is -1, m is -2, x is -3, and we are solving for b. So let's see, it's going to be 6. Let's subtract 6 from both sides. We get -7 is equal to b, and now we've got to just write our equation. And we write in y equals mx plus b, substitute in for m, which was right here, our -2, and now substitute in for b, -7, and there's our equation, y equals -2x minus 7. Let's do the same thing here. Let's find our m, x, and y. -1, 3, 8, 3. So our change in y is +0. Our change in x, +9. Our slope is change in y over change in x. So that's going to be 0 over 9, which makes our slope 0. Now that should be kind of a red flag right there. Slope of 0, horizontal line. Okay, and horizontal lines, those equations are y equals a number. Y equals the y value. So at this point, I can answer the question. I can say y equals 3. If I didn't realize that, because it's a horizontal line, I could have taken the steps to solve for b, chosen an ordered pair, let's say 3, -1, sorry, -1, 3. Anything times 0 is 0. So 3 equals b, right? Either way, we get to that y equals 3. 12, we're going to determine the equation of the line in slope-intercept form that goes through the following ordered pairs. Okay, so really same thing here. Find our m, right? Here's our x and our y. We've got -2, 1, -3, 4. Change in y is +3. Change in x is -1. So our slope, change in y over change in x, is going to be 3 over -1. So -3. M equals -3. Now let's find our b. Maybe I'll use this pair. Y equals mx plus b. So let's see. Y is 1. M is -3, x is -2, so that's going to be 1 equals 6 plus b, subtract 6 from both sides, -5 equals b, and we'll write our equation. Boom. So we've got y equals mx plus b, substitute in for m, substitute in for b, and there we are, y equals -3x minus 5. There's our answer. Determine the equation of the line that goes through the ordered pairs. Now we go on to b. 2k minus 2 is a solution of the equation in part A. Find the value of k. So I want to notice that this is given to me as an ordered pair, and I'm told it's a solution to our equation in part A. So we're going to have to use that. We have to use that y equals -3x minus 5. And substitute in for x and y. So y is k minus 2. We've got our slope of -3. Now substitute in for x, which is 2. And we'll solve for k. So that's going to be -6 minus 5. K minus 2 equals -11. Add 2 to both sides. K equals -9. So we had to do that part A in order to answer our part B. Now number 13, determine the equation of a line in slope-intercept form that is parallel. As soon as I see parallel, I'm thinking same slope to the given equation and passes through the given point. So remember, we're going to split our work with the given and then that new parallel line. We got y equals -2x plus 4. From that, we take our slope, -2. Our new parallel line, right? We're going to have an x, a y, an m, and a b. We're solving for b, so that'll be our unknown. Our slope is going to be the same because it's parallel. So that's why we're saying the slope is -2. And then we'll take our x and our y from the given point. So substitute in, and we will solve for b. Add 4 to both sides. We get 1 equals b. And now we write the equation. So we're going to take that new slope, new y-intercept. And there is our new equation of the parallel line. Ooh, B, little curveball here. Can't take the slope yet. It's not in slope-intercept form. So let's subtract x from both sides. We get 2y equals -x plus 8. Divide both sides by 2. Y equals -1/2 x plus 8. Now we can get to work with our given and our new parallel line. Right, so that given, y equals -1/2 x plus 8, we know the slope is -1/2. So we'll take an x, a y, our m is going to be -1/2. We're going to solve for b. It's the same slope because we're talking about parallel lines. So then our x is -4, our y is 1. Substitute in. 1 equals -1/2 times -4 plus b. -1/2 times -4 is +2. Subtract 2 from both sides. Ooh, again we get a b. This time it's -1. Got our slope. So our equation, y equals -1/2 x minus 1. On page 4, number 14, we're determining the equation of a line in slope-intercept form that is perpendicular. As soon as I see perpendicular, I'm thinking of those negative reciprocal slopes to the given equation and passes through the given point. So we're going to separate into given, and then now it's new perpendicular line. So that given is y equals 5x minus 1. And we know the slope is 5. We're going to write our equation y equals mx plus b. We're going to get x, a y, an m, and a b. We're going to solve for b. This time our slope is going to have to be the negative reciprocal. So 5 or 5 over 1, we flip and change the sign. So that means our slope, our new slope is going to be -1/5. Take our ordered pair, 10, -1, substitute in. -1 equals -1/5 times 10 plus b. -1/5 times 10 is going to be -2. So we'll add 2 to both sides. And we get -1 is equal to b. Now we write our equation with our new slope, new y-intercept. Y equals -1/5 x minus 1. Ooh, and it shouldn't be -1, it should be a +1. So let's go fix that in there. Boom! Found that error right there in the nick of time. Y equals -1/5 x plus 2. On B, that equation they give us isn't in slope-intercept form in the slightest. It's a hot mess, so we got to put it in slope-intercept form. 5 plus 6y equals -3x. Now we'll subtract 5. 6y equals -3x minus 5. Divide both sides by 6. So we get y equals -1/2 x minus 5/6. Okay, so we've got our given, and then that, I guess I'll go over here for that new perpendicular. So that given was y equals -1/2 x minus 5/6, where we're going to use our information of slope. Now we have to do the negative reciprocal. The negative reciprocal of -1/2 is going to be +2. And then our x was also 2, y is 1. And we'll substitute in. And we get -3 is equal to b. So we're going to use that new b, new m. Y equals 2x minus 3 is our answer. 15, a little different. The following equations, y equals a plus 2 times x plus 3 and y equals 5ax, give the graphs of lines that are parallel. Parallel, same slope. Find the value of a. So one of the things I want to notice here is, where are those a's located? They're right here in the coefficients of x, which put them in that m spot in our equation. So those are the m's, those are the slopes. We know they're parallel. Parallel are same slopes, which means they're equal. So I'm going to use that to my advantage, and I'm going to set them up equal to each other. A plus 2 equals 5a. Now just solve for a. And we get 1/2 is equal to a. 16, finally we get to do some graphing. We're going to graph our linear inequalities and label the solution set. So we've got y is greater than -1/2 x plus 3. I want to notice our slope is -1/2. Our y-intercept is 3, our starting point. I also want to notice the inequality, that it's going to be that dotted line and that we're shading above because it's a greater than. So we started our y-intercept 3. Slope of -1/2 tells me go down 1 to the right 2. Do that till I run out of room. Go up 1 to the left 2. Take my straight edge, and we're going to do that dotted line. So I'll pick up my pen every once in a while. Okay, arrows on each end. Okay, shading above the line. I could do a test point if I wanted to. Greater than, where my y value is greater, all up here. So that's where my shading will be. Do it nice and controlled, not too big. And I'm going to label my my inequality with the line. Okay. Now x is less than 6. I want to notice, ooh, that's a vertical line. And it's also going to be dotted. Right? So vertical line, x is less than 6. So we're going to go to 6 on the x-axis. It's going to be dotted. So a dotted vertical line. There we go. I'm going to label it. X is less than 6. Now I want to think, well, where are the x values that are less than 6? They're all here to the left. So I'm going to shade to the left. And like I said, I like to change my angle. And notice I'm going all through the coordinate plane on the left side. I'm not stopping where our other inequality is. Okay? And then we just want to label our solution set, which is right here. And so we put that S. Good. On B, I want you to notice this inequality is not in slope-intercept form with that negative there. Instead, we have to divide both sides by -1. So we get y is greater than or equal to. We had to flip because we were dividing by a negative. So we get y is greater than or equal to -2x minus 1. Okay, that equal to tells me it's going to be a solid line, right? Greater than, I'm thinking about shading above. So we also notice, right, that slope is -2 or -2/1, and our y-intercept is -1. So I start at -1 on the y-axis. Slope of -2/1 tells me go down 2 to the right 1. So I'm getting that nice negative slope. or up 2 to the left 1. Like we said, we're doing a solid line. Greater than, where are the y values greater in relation to my line? They're right here. So I'm going to shade this way on my line. So I'm including all those big y values on the y-axis. And don't forget to label with the inequality. And then y is greater than or equal to x minus 6. Again, we're going to have that solid line. And again, it looks like an above shading. Okay, so we've got a slope here of 1, or 1 over 1 is a fraction, and a y-intercept of negative 6. So negative 6, up 1 to the right 1, up 1 to the right 1, or down 1 to the left 1. Get our nice solid line. Where are the y values greater? They're all up here. Those are where our bigger y values are. So I'm going to shade this way. Above the line. Greater than, above. And can't forget to label. Okay. And then put in our solution set. On our fifth and final page, we're graphing systems of equations, and we're going to look for the solution. Remember, that solution is that point where they intersect, and we should see it as a perfect point unless the lines are parallel where we're seeing that same slope. Okay, so y equals x minus 2. It's in slope-intercept form. We've got a slope of 1, a y-intercept of negative 2. So we start at negative 2, and then we go up 1 to the right 1, till we run out of room. And since it's an equation, obviously we're using a solid line, right? Equations are always solid lines, and there's no shading here. All right, we just make our line and label it. Arrows and label. Okay. Now y equals 3. I want to notice, right, that's a horizontal line. So I just go to y equals 3. 3 on the y-axis. We're going to make that horizontal line. There we are, y equals 3, and I look for their intersection point. There it is, right there. I'm going to label it on the graph for myself, 5, 3, and then state that as our solution, the ordered pair, 5, 3. Great, so fun. Let's do it again. Okay. Now this equation is not in slope-intercept form, so let's first get it there. 2y equals negative 3x plus 2. Let's divide both sides by negative 2. So y equals 3 over 2x minus 1. So now we see a slope of positive 3 over 2. That'll be fun. And a y-intercept of negative 1. So let's start there. Negative 1 on the y-axis. Now a slope of 3 over 2 tells me go up 3 to the right 2, up 3 to the right 2, up 3 to the right 2, and then reverse it, down 3 to the left 2, down 3 to the left 2, down 3 to the left 2. Okay, and again a solid line because it's an equation. Arrows and a label. Now y equals negative x plus 4, that's our slope of negative 1 or negative 1 over 1, and y-intercept of 4. So y-intercept of 4, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, and so on. Or up 1 to the left 1. Create our line. Label, and I'm looking for my intersection point. There it is right there, the ordered pair 2, 2. label it right there as our solution. And that's it. That's all she wrote.